Hello! Today I want to talk about AI-based test generation and what you can do to automatically come up with automated tests that are being generated by an AI. Maybe you know that today 99% of the companies face challenges in testing and test automation. And AI, being a buzzword recently, has come to the attention to address that problem. Testing in general is considered the bottleneck in software development, so there's definitely a need here that needs to be addressed. However, it's not that easy. AI-based test generation faces three main challenges. One is the Oracle problem, meaning to identify what is actually defect. So how does a defect look like? What does a bug look like? Like if it's a technical bug, if the software crashes, then it's obvious. But in most situations, there's a button that you press and nothing happens, or there's an image that is missing that's not being loaded, or a button that is off the screen or hidden by some other element. So how do you identify such a problem when you see it? The second challenge is coming up with meaningful tests, meaning that it doesn't suffice to generate tests that just cover a lot of the application functionality. You want to do so in a meaningful way, following user stories or happy paths. And the last challenge is test maintenance. When you manually create test automation, you usually use specific paradigms like single page object pattern and whatnot, and machine-generated tests do not do that, so it's very hard for humans to actually maintain those tests once that's needed. So let's see how ReTest addresses all three of those challenges. First of all, the Oracle problem, the main problem of test generation. So how do you know that there is a problem when you see it? Well, we do so by defining an allow list or an ignore list of changes, meaning that you can on a global level define semantically what you care about and what you don't care about. And whenever that changes, you get notified. The benefits of that is that it's more complete in what is being checked and more robust at the same time, and it even catches unexpected changes, which is very hard to do when you have to write assertions, because usually you don't write an assertion for something that you don't expect to happen. We have three use cases for that, and there are many more. These are just a couple of examples our customers use or do. So one is if there are two different, say a test system and a production system, and you can just ignore irrelevant changes. In that case, you want to ignore text of, say, the definition, the price, the headline, and maybe the photos, and you only want to see the changes that are relevant. So in that case, we spotted that there's actually an element missing, and we check that there is a price. However, we ignore the concrete price. So we ignore which price it is as long as there is a price, for instance. Another example is if you have a component that is being reused in different contexts, and you want to make sure that in each context the component looks the same. And third example, if you do cross-browser or cross-device testing, then you may care about a change of 50 pixel, like if an element moves in the range of 50 pixel, but if it's below a certain threshold, say 10 pixel, then you don't want to see that. So you can very specifically define what you care about. The second challenge with AI-based test generation is coming up with meaningful tests, meaning that tests that are actually something that a user or tester can relate to, or a developer can relate to. So what we do here is, first of all, we combine two different AI approaches, because as you know, with neural networks, you usually have the problem that you need hundreds or even thousands of test examples or examples to train the neural networks. And we solve that problem, we address that problem by coming up with a pre-trained neural network that knows how a typical user uses a typical website. And then you can come up with only a couple of examples that are needed for your specific project or website. And the idea is generally that the AI follows the nudges to come up with a user story. I'll come back to that in a second. And the best of that is that it gives you even feedback on how well or how fine-tuned your own website is when it comes to these nudges. So let's have a look. In that case, we want to test a web shop, and as you can see, those buttons or those links that the AI should click are the ones that are highlighted, and with that it follows a simple checkout procedure. So this is the main use case of a web shop, obviously, and just by following the nudges that the developers and designers of the system gave to the user, the AI has an idea of what the people expect the AI to do. So the first user story that the AI will generate for the web shop is actually ordering something. And as I said, this gives you even feedback. So you can say, okay, how fine-tuned is my own web shop or my own website for this specific functionality? Like, would the AI pick up on the clues, or do I have to do better? Do I have to give more guidance to the users? And the third and last problem with AI-based test generation, with machine-generated automated tests, is test maintenance. And for that, using the golden master approach, we come up with unbreakable tests that are auto-healing, and using the ReTest ID, you have a virtual constant identifier, meaning that even if an element changes completely, you can still very robustly, very correctly identify that element, continue with that, and still follow the test case. I want to just give you a very brief example of that. So this is a typical test case. If you execute it, you will see that it logs in, finds the element by the IDs, logs into, fills username, password, presses sign in, and logs into the system. And the test is green. Now the problem is, if you change, say, a single character, then the CSS of that website is broken, and from a user's perspective, it's pretty much unusable. However, all that is checked is that the success message is being displayed, which still is, and so this change goes unnoticed by the test. However, if you instead change, say, an ID from username to user and try to execute the test, because that ID is being used in the test will break, and the test system will be unable to identify the element, and therefore the test breaks. Now, if you instead use, let me undo that, if you instead use recheck, all you need to do is wrap your driver into a recheck driver, and then you can get rid of the assertions. Still, if you execute the test, again, breaking the CSS, the website is now, from a user's perspective, pretty much unusable, as you can see. However, this time it gets detected. So this time you see that there's 179 differences, which should, tell you that there's something wrong. Again, if you change the ID from username to user, and here this ID is being used as well. So as you can see, these are identical tests in that regard. However, because we now have the golden master, we can still correctly identify the element, because we've done so in the past. We know how it looks like, and can still execute the test. So the state of the art is a test that ignores changes that are very relevant to the user and fails on changes that are irrelevant, because the idea is never even displayed on the website. However, we change that to tests that fail on changes that are relevant to the user, but ignore changes that are irrelevant to the user. So as you can see now, the change in the ID is detected, and now if you say you accept that change, here is a marking that says that accepting this change will break the test. Now if you accept it and apply the change, even the Java file is being updated, and as you can see here, now has a new ID. So this is an example of both unbreakable tests, as you saw, and auto-healing tests. And now you can go one step further using the ReTest ID, meaning that you don't even have to use an actual ID on the website. The idea of the ReTest ID is, with Golden Master Testing, we essentially create a copy of the website. Now we introduce an additional identifier into the copy on the website that's not even displayed, so it cannot be affected by change, meaning that you can always reference that element using that ID, and however the website changes doesn't affect that ID. This gives us an overall ecosystem where you can have manually automated tests or AI-based automated tests, or even manually compare websites using the Chrome extension. Then you can store the diffs locally or in our cloud, and you can use the CLI, the open source CLI, or the review GUI, and use the AI to actually generate tests. People that have tested it pretty much liked it, and it's open source part of it, so you can try it yourself. And if you want to know more, please contact us. Thank you.